Today we are talking about exterior angle theorem and the perpendicular bisector theorem. There's a couple different things with these that we won't quite have time to get into, mainly the perpendicular bisector theorem. There's another angle bisector theorem that we won't touch today. The objective is students to be able to use exterior angle theorem and the perpendicular bisector theorem to solve for missing variables. So this is an interesting one because we already know how to do this. It's just a warm-up, but I want you to do this on your own and then hit play and see how I'm going to do it. So the whole point of that is there actually is two different ways to do this. One way you could look at this is some of you are going to say, all right, we have a triangle right here. So all three of those angles have to add up to be 180 degrees. So x plus 42 plus 37 is 180. 42 plus 37 is 79. Subtract 79 from both sides. You end up getting x is equal to 101. But the other way to do it, as some of you guys noticed, is you could also say, well, yeah, but this makes up a straight line where 79 and x, if you use the linear pair postulate, 79 plus x has to be 180. If I subtract 79 from both sides, I get x is equal to 101. So there's two separate ways to do that. So we'll probably come back and look at this after we kind of get started here. But a couple definitions. So the exterior angle of a polygon is an angle formed by a side of a polygon and an extension of an adjacent side. So what that means is the big thing is that you're extending it. A lot of people think that an external angle is this angle right here. But that's not the external angle. The external angle is when we have to take a side and we have to extend that. So if we extend it, this angle is an exterior angle. And it doesn't matter whether you extend that one or if you extend this one, it still makes those two exterior angles. And it doesn't matter which side you do or which angle you're using, but you have to make sure you're extending that. And the adjacent side is just, obviously, you're extending the side that is right next to the angle we're talking about. So a remote interior angle is the angles in a polygon that are non-adjacent to the exterior angle. So we already talked about interior angles, where the angles inside of a triangle. The remote interior angles are the ones that are opposite the exterior angle. So for instance, if you're looking at the two triangles down here, angle 1 in both of those are exterior angles, 2 and 3 are remote interior angles. Now again, one thing you'll notice, the reason that 2 and 3 are remote rather than just interior is they are the opposite of your exterior angle. Those aren't congruent, I'm just making sure you can see what those are. Same thing over here. This is my exterior angle, so my remote ones are the ones that are opposite that. They're not right next to it. That's what non-adjacent means. They're not right sitting next to it. So the triangle exterior angle theorem, the measure of each exterior angle of a triangle equals the sum of the measures of its remote interior angles. So really what that means, if we're looking at this triangle over here, is if you have an exterior angle, that's the exact same, that's got to be equal to if you add up the other two angles that are not touching it at all, the ones that are the opposite of that. So if we look back at the one we started with, we could have found this one, or one thing you'll notice with this is that this 79 is the same thing as 42 plus 37. 42 plus 37. And it makes sense if you actually look at this, because the way we solved it up here, we ended up with x plus 79 is equal to 180. Same thing over here, we ended up with 79 plus x is equal to 180. So the whole thing with that is the fact that all three triangles have to add up to be 180, but also these two make a linear pair that adds up to be 180. I'm not going to go into too much depth with that because I don't want to confuse anybody, but that is why that exterior angle theorem exists. So to find these, the value of the question mark shouldn't be too bad, or variable. Some of them are going to be an x. So if I'm looking for this angle right here, it's just these two angles added together. So 50 plus 30 is equal to that question mark. So that question mark is 80. That's all there is to that one. Now again, you could actually use the third angle theorem on this, where we know all the angles inside of a triangle have to add up to be 180, because I know 50 and 30 and this angle have to add to be 180. So that ends up being 50 and 30 plus x is 180. When you solve that, you end up getting x is equal to 100. Well, if I get that that angle is 100, then this makes up a straight line, so I know that has to add up to be 180. That means this question mark has to be 80. So you don't actually have to use the exterior angle theorem if you forget what it is. There's other ways to find it. So same thing with this one. We have 134, we have question mark and 80. So I know that the question mark plus 80 is equal to 134. 134 minus 80 is 54. Now, I won't do this every time, but again, just to make sure you realize, you could use something else to find this. So I know 134 and this make up a straight line. They have to add up to be 180, so this has to be 46. Well, now again, I know 46 plus 80 plus this question mark have to add up to be 180. So 46 plus 80 is 126. Subtract 126. And getting 54. So it doesn't matter which way you do it. This way is just way longer. It takes a lot more work, and that's why we found out this exterior angle theorem. Now, problem like this, they could even make it a little bit harder where there's more solving involved. But again, don't make it harder than it is. This is my exterior angle. These are my remote interior angles, the ones that are opposite of that. So these two have to add up to be this one. So 3x plus 10 plus 2x plus 10 has to add up to be 70. So again, 3x plus 10 plus 2x plus 10 has to add up to be that 70. So now it's just an algebra problem. Combine your like terms, that's 5x plus 20 is equal to 70. Subtract 20 from both sides, 5x is equal to 50. Then divide both sides by 5, x is equal to 10. Now remember on that last one I said, both of these, there's other ways you can do it where you find this angle and then you use your angle sum theorem. Technically you could do that one with this one. It's just, again, it's going to be a little bit more of a mess. This one actually wouldn't be too bad. That's 110, and then all three of those add up to be 180. But again, if you end up doing that, I won't finish this, but just an interesting fact, plus 110 is equal to 180. If you subtract 110 right away when you're solving this, now all of a sudden we have exactly where we started. Because that's going to be 3x plus 10 plus 2x plus 10 is equal to 7. But it would be possible, just there's a little bit more work. So go ahead and do these three on your own. And then, so pause it, do these three, and then hit play so you can check your work. That's definitely going to help you with these. So this one's 118. We have these two have to add up. So 64 plus question mark is equal to 118. Subtract 64. 118 minus 64 is 54. This next one, again, we have some algebra. This one is these two added together. So 7x minus 4 plus 33 is equal to 10x plus 8. So it's a little bit different than the last one, mainly because we had the binomials are in different spots. But again, it's the same thing. Combine your like terms. That is 7x plus 29 is equal to 10x plus 8. Subtract 7x. 29 is equal to 3x plus 8. Subtract 8 from both sides. We have 21 is equal to 3x. Divide both sides by 3. That ends up giving you x is equal to 7 for this one. Now, please realize, this one with the question mark, we found that this was 54. That angle is 54 degrees because the angle is the question mark. Over here, the angle is not 7. You would have to sub 7 in for x to find out what these two angles are. So just be aware of that. And this last one, again, we have these two added together is equal to 25x plus 5. Can't really combine like terms in this one, so subtract 10x. Subtract 5. 75 is equal to 15x. What's that, like 5 maybe? 4? I don't know. Probably way off. 5. So x is equal to 5 for that one. Again, even these, there's ways to do it without using this and using the angle sum theorem. It's just kind of confusing and a lot more work. So we just did the exterior angle theorem, so that's great. Now we're going to move on to the perpendicular bisector theorem. So this is what the textbook says. The textbook says if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoint. So this isn't even talking about triangles. It's just saying that if we have this line segment, and I know that this other line segment or line is perpendicular, and it's right in the middle, so that means these two are congruent to each other. That means no matter where you put this point P on here, it's going to be the exact same distance from both endpoints, no matter where you put it. So that's what this is saying. There's no triangles at all, and this is the perpendicular bisector theorem. The perpendicular bisector theorem has really very little to do with triangles. However, it ends up making a triangle, or several triangles. So I changed this to fit what we're going to use. So for our purposes, it's going to be triangles, and it's going to be the base of a triangle is bisected, if the base of the triangle is bisected by a perpendicular line, then the other sides, which are legs, are congruent. So if we have a triangle where we have this perpendicular base, it's perpendicular to the base, and it is congruent on both sides, that means that these two sides have to be congruent to each other. Now, again, I'm sure a mathematician would look at that and say that that's not exactly the perpendicular bisector theorem, but for our purposes, that's going to be easier to remember. That's going to be easier to work with. So that's what I'm going to go ahead and stick with. So solve to find the variables. So again, we're using the perpendicular bisector theorem. So this one, there's a couple different things. First off, we know it's perpendicular and it is bisecting. It's the midpoint since these two are congruent. So that means these two are equal to each other. So 3x is equal to 9x minus 18. So subtract 9. Negative 6x is equal to negative 18. X is equal to positive 3. So that's great. But this one, I also want you to find y. Now, this one is not part of the perpendicular bisector theorem at all. It's that we have 3 angles in here, and they all have to add up to be 180 degrees. So actually, there's a couple different things we can look at. So 40 plus this one right here is 90, plus y is equal to 180. That's 130 plus y is equal to 180. Subtract 130 from both sides. You end up getting 50. Now, the other way you could have done that one is you could have also realized that if this is 90 degrees, this is 90 degrees. That's an exterior angle. This is an exterior angle. So these two have to add up to be that one. So 90 has to be 40 plus y. So you end up getting 50 is equal to y. So either one is fine. Most of you guys probably would have noticed the first one just because that's what angle they labeled. If they would not have labeled this one, they would put it over here. Maybe more of you guys would have thought about this green option, but either way, you get the right answer. So it doesn't make any difference. So again, go ahead and pause this, do this one on your own, and hit play to make sure you check your work. So again, we have perpendicular bisectors, so these are congruent. So 3n minus 1 is equal to 5n minus 7. -1 is equal to 2n minus 7. Whoops. 7. N is equal to 3. Then again, now we have to solve for y. Now again, it's a little bit different with this one. So make sure you're thinking outside the box. Make sure you realize that since this side and this side are congruent to each other, what we really have is one isosceles triangle. Well, if we have an isosceles triangle, that means this angle and this angle are congruent to each other, so y is equal to 25. But those are going to be the ones that I'm nervous about on the test, where you have to think outside the box a little bit. So we have obviously a perpendicular line that's bisecting it, so that's pretty obvious. But that then forms a isosceles triangle. Maybe that's how I should have said this theorem. Maybe I should have said, if there's a perpendicular bisector to the base, it forms an isosceles triangle. Maybe that's another way to say it. So the next ones are a little bit, I would say, I don't want to say challenging problems. They are a little bit harder. But again, the math isn't too bad. You just have to make sure you're piecing together what we know. So there's a lot of them that you're going to get a little bit confused with, but if you just kind of piece together things that we know, I think it's going to help you. And all of these, there's several different ways to do this. So pause it, do it on your own. If you get stuck or when you're ready to check your work, go ahead and hit play. So for the first one, if we just start by looking at this small triangle, I think that's the easiest way. So we can solve for x. So 30 plus 80 plus x is equal to 180. That is 110 plus x is equal to 180. If you subtract 110, you end up with x is equal to 70. So this angle is 70. So that helps us with that one, but what else can that help us with? Well, again, now we have a straight line, so we can find y. 70 plus y is 180, so that's got to be 110. And then now we have three other angles that have to add up to be 180. 40 plus 110 plus z is equal to 180. So that's 150 plus z is equal to 180. That ends up getting z is equal to 30. So x is 70, y is 110, z is 30. Now again, there's several other ways we can do this. Angle y right here is an exterior angle, so I know that's got to be 30 plus 80, so you could have found y first. The other thing you could have done is you could have realized that this whole angle right here is 70, 30 plus 40, so 80 plus 70 plus this has to add up to be 180. That'll get you z. So again, there's several different ways you can do this one. This next one, actually, it should be easier than that one. If you start by x, 70 plus 30 plus x is equal to 180. That's 100 plus x is equal to 180. Subtract by 100, you end up getting 80. Oops. Then these are vertical angles, so y is also 80. Now, a couple people might be thinking, well, wait a minute, but that can't be 80. It's an exterior angle, so it's got to be 70 and 30 added together. No, you're close. I like the way you're thinking, but this is not the exterior angle. This is an exterior angle, so that would be 100. Or this can be an exterior angle. That would be 100. But again, you can kind of see if it's 100, then that's going to force these two to be 80. They're all vertical angles, all those pairs at least, so they're congruent. Again, a lot of different little ways you could do that one. So let's see. I say the best one to do this one. They don't have these angles labeled at all, but I'm going to solve for this one first. So 50 plus 25 plus x is equal to 180. 50 plus 25 is 75. Subtract 75 from both sides, that ends up being 105. So this angle is 105. So this angle also has to be 105 because they're vertical angles. And now we have another triangle. So 105 plus 35 plus question mark is equal to 180. So that's 140. Subtract 140 from both sides, your question mark ends up being 40. And this last one, I really like this one because it's just, you kind of have to think outside the box. And when you notice it, it kind of clicks. So I was thinking that they probably said this one was congruent to this one, but they're not saying that. They're saying that these two are congruent down here, and these two are congruent to each other. So if you see that, if you get stuck, realize that they're isosceles triangles. Well, that's going to help us because if they're isosceles triangles, this is the base of the first one. So if this is 58, this one has to be 58. Well, that doesn't help us for x a lot. But 58 has to also be 58 over here because it's a vertical angle almost at reflection. Those are vertical angles, so they're congruent to each other. Well, again, that doesn't help us find the x too much. Well, but this side and this side are congruent, so it's isosceles, so now this one's also 58. So we just found 3 angles without really doing any math, just knowing what those congruent statements, or knowing those theorems that make those congruent. Now we can solve for x. 58 plus 58 plus x is equal to 180. 58 and 58 is 116, I believe. Subtract 116. Ends up giving me 64. So on the test, I do think you maybe have one of those. And again, it's not too bad. You have to make sure you're checking all your options. If you're stuck, start looking for vertical angles. Start trying to see if you can find angles in a triangle by making sure they add up to be 180. Try to look for the linear pairs that make up a straight line. All those little things, if you keep chipping away, a lot of times will eventually give you enough information that you can solve. If you have any questions, make sure you let me know. Thank you.